So now we're going to talk about relative frequency. So we have to do a couple of different definitions here first. So it's going to take a little bit of time. So relative frequency is how often something happens divided by all outcomes. Okay, so relative frequency is how often something happens divided by all outcomes. Okay, and there's different, relative frequency is really the same thing as probability, right? And probability we could split into experimental and theoretical. So relative frequency is pretty much just saying to find the probability. So find probability, which we talked about. And last thing, how probability is expressed and all that fun stuff. So let's talk about experimental probability. So experimental probability is what it sounds like. So it's the probability. So it's the probability determined. The probability determined by the results of an experiment. So it's a results determined by an experiment, and what that really means is it's the number of successes. Number of successes over the number of trials. So how many times did our experiment work out of the number of times we've experimented? Theoretical probability is kind of what we've done before. So it's a mathematical way to determine so it's a mathematical way to determine the probability of an event occurring. So we would say the number of favorable outcomes over the number of possible outcomes. So we talked about this in our last notes. So really, like, how many times that was true or how many times it could happen out of the number of total possibilities there are. Let's kind of go back to what a trial is. So back to experimental probability, what a trial is. So a trial is a single performance of a probability experiment yeah. Okay. So now that we've talked about all those things, we're going to go through a couple of examples. So use the spinner to complete these questions. Find the theoretical probability of spinning a 2. So first, find total outcomes. So total outcomes. Find the total outcomes. There's 8, right? So how many times do you see 2 on the wheel? Well, I see 2 on the wheel here, and that's just 1 time. So that's my probability, 1/8. Remember, if I can, I want to simplify. I can't simplify 1/8, so then I move on to the next question. What's the probability of spinning an even number? Okay, so even numbers. 2, 4, 6, 8. That's 4 out of 8 total. So how can we simplify 4/8? Well, 4/8 we could simplify to 1/2. All right. Let's just keep on going. We'll do this whole example together. What's the probability of rolling a 5 or a 7? Since it says or, we want to add them. So I see a 5 and a 7. How many total possibilities are there? There's 2 out of the 8 outcomes. 2/8 I can simplify to 1/4. What's the probability of rolling a 2, a 4, or a 6? Well, that's 3 out of 8. All right, here's kind of a logic question. How many times would you expect to land on a 2 or a 3 after 8 spins? So how many times would I expect to land on a 2 or a 3 after 8 spins? So think about that. What's my probability of it spinning a 2? Well, 1, right? A 2 is 1/8. What about a 3? A 3 is also 1/8. So if I spin 8 times, what do you think? How many times do you think I'll land on each? I'd land on each 1 time. So since it says or, I combine those. So it's going to be twice. I should land on them twice. Or once each. Right? Hopefully that kind of made sense. So this says a quality control inspector found flaws in 13 out of 150 sweaters. So what percent chance is there that a sweater has a flaw? Well, they gave us that. They gave us 13 out of 150. But this says a percent. So I want to take this fraction, I want to turn it into a decimal. So do 13 divided by 150. So in your calculator, do 13 divided by 150. What does that give me as a decimal? Round to the 10th place. That gives me 0.09. And remember, to move that to a percent, I just move it twice, and it's 9% chance. So you can either move the decimal twice, or you can multiply by 100. And that's where I get that 9% from. So now we're going to do something else here. It says, suppose the company produces 500 sweaters a day. So suppose they set up 500 sweaters. How many will have flaws? Well, we're going to use a proportion. Remember part over whole? So they gave us their original. They gave us 13 out of 150 had flaws. We want to know, out of how many 500 sweaters, how many will have flaws? So we set it up like that. We cross multiply. So remember, we multiply diagonally. So we do 150 times x, which is 150x. And then we do 13 times 500, which 13 times 500 is 6,500. Divide by 150. We get x equals roughly 43 sweaters, right? If you get a decimal, I can't have a percentage of a sweater, so I'm going to round up, okay? I'm going to do one more example with you, and then I'm going to let you do a couple on your own. So Duncan rolled a regular die 10 times. Use the results below. Here's his results. Find the relative frequency of the following, or the experimental probability, right? So that was the out of total, how many were true? Okay, so how many total times did he roll? Well, he rolled 10 times, so my denominator is 10. How many times did he roll a 2? He rolled a 2 once, and that's it. Rolled it 1/10. How many times did he roll an even number? An even once, twice, 3 times, 4 times. He rolled an even number 4 out of 10, which I can simplify to 2/5. How many times did he roll a number less than 3? So less than 3 is either going to be 1 or 2. Can't include 3. So 1, 2, 3, 4. He rolled less than 3, 4 out of 10 times, 2/5. All right, so I want you to try 4 and example 5. So I want you to try example 4 and example 5 on your own. Okay, so stop there and I'll go over a couple there. So pause, try example, try example 4 for now. So pause and try example 4. All right, so you're going to pause and try example 4. All right, so hopefully for answers, you got 1/3 and 2/3. So you had to count how many there were. There was 15 total times they flipped the coin. Okay, 10 of those times were tails, 5 of them were heads. So tossing heads was 5/15ths, which simplified to 1/3. Tossing tails is 10/15ths, which simplified to 2/3. All right, so we're going to start example 5 together, and then I'll let you go from there. Okay, so an experiment consists of drawing a marble out of a jar. The jar has 10 red, 10 orange, 13 red, 25, and 32 blues. Find the relative frequency. So first, we always find the total outcomes. So how many are in the jar? Well, you should be doing 10 plus 13 plus 25 plus 32, right? 10 orange, 13 red, 25 green, and 32 blue. So add those all up for me. So add those all up and figure out how many total are there. Hopefully you are saying there's 80 in total, right? So what's the probability of finding a orange marble? Well, there's 10 orange. So we'll do 10 out of 80. And you're going to simplify that fraction. So 10 out of 80 is 1/8. This next one says drawing a green or a blue, right? So you add those up. So our total is out of 80. How many greens are there? 25. How many blues are there? 32. So add those up. 25 plus 32 gives me 57/80, which can't be simplified. All right, I want you to try the next two on your own, and we can talk about those next time I see you in class. So try these two, drawing a yellow marble and a red or a green. So try those two on your own. We'll talk about those later.